Welcome to Unit 10 video on skill number 68. I can use nets, cross-sections, and diagrams to classify and analyze three-dimensional figures according to their properties. We'll begin our notes on page 68A. Three-dimensional figures can be made up of flat or curved surfaces. For example, a cube, like a dice that you roll, has a flat surface, whereas like a can of soda has a curved surface. So a flat surface is called a face. The edge is the intersection of two faces, and in this diagram here we can see that we have an edge here, there's another edge right here, another edge here, another edge. So there's several edges on this diagram. We also have several faces. This is like a squashed cube, so what we have is 6 faces. And then the vertex is the intersection of 3 or more faces. The vertex is a point, so all 8 of those points. There's actually an interesting formula that you don't need to know. It's called Euler's formula. The formula is V minus E plus F equals 2, which is vertices minus edges plus faces equals 2. And if we do it for this diagram, you'll see that what we have is we have 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. Edges, we have, there are 12 edges. We've got the 4, 1, 2, 3, 4 on top, the 4 on bottom, and then the 4 vertical ones for a total of 12 edges. And then faces, like I said, this is kind of like a cube, so you have 6 faces. So we can add 6, and we find that 8 minus 12 plus 6 is indeed 2. This occurs for all three-dimensional figures that are made up of flat surfaces. It's a pretty fascinating formula that's complex. We don't need to know it, just thought I'd share it. On the skill test, we will need to be able to identify edges, vertices, and faces. So I've given a couple examples. Edges are line segments, so we use the notation for a line segment. Vertices are points, so we use the notation for a point. And then the faces are faces or planes, so we use the letters that outline the face. The next term is net, and a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the 3D figure. So if you take this diagram right here and you were to cut it out and fold it up, you would find that it makes a triangular pyramid. The net below that is composed of all these squares. If you were to cut it out, it makes a cube. If I wanted to make the net of a cylinder, I would have a circle for the base, I would have a rectangle for the edges, and then I would have another circle for the base. So we could fold these down and wind up making essentially a cylinder. On the skill test, I will have several different nets, and you have to identify what type of shape they are, whether they're prisms or pyramids, triangular prisms versus triangular pyramids, hexagonal pyramid versus hexagonal prism, etc. And we'll use page 68B for identifying these. So a prism is formed by 2 parallel congruent faces called bases, connected by faces that are parallelograms. So in this diagram, these 2 triangles are the bases, and they are connected by these parallelogram type shapes. One possible way that you can think of it is you have some sort of shape. Maybe I've got a pentagon right here, and what I do to the pentagon is I extrude it upward. So I push it up along an axis, and it goes up, and in the end we get another prism. This would be a pentagonal prism. A cylinder is basically a circular prism. I wouldn't call it a prism, but it is a circle that's been extruded. It has congruent bases, so the top circle and bottom circle are of the same size. A pyramid is when you take a shape and you extrude it upwards to a single point, called the vertex of the pyramid. So we're pretty familiar with the pyramids at Giza, where you start with this square base and all the edges connect up to a singular point. So that singular point is the vertex of the pyramid. So a cone is formed when you take a circular base and you have this surface that is connected to the base that meets at a single point. It's kind of interesting, the net for a cone winds up looking like something to this effect. I'm sure you are pretty familiar with it, what a cone is shaped like based off of waffle cones, ice cream cones. Alright, the last term that we should be able to identify is a cross-section. And a cross-section is the intersection of a three-dimensional figure and a plane. And I've drawn two cross-sections here. You can see what I've done is I've taken a triangular pyramid, and this triangular pyramid has been intersected by a plane. And that created a triangular cross-section. So this part that I'm outlining in blue is called the cross-section. If we were to take a plane and slice it through a cylinder, we're going to get a circular cross-section, or perhaps elliptical. If we cut it through the cylinder diagonally, what we wind up getting is a elliptical cross-section. Alright, the key ideas and concepts for this skill. We should be able to look at nets of three-dimensional figures and figure out what sort of shape they are. For example, here is a hexagonal shape. 5, 6. And if we were to fold that up, we would have a hexagonal prism. We should be able to look at a three-dimensional figure and identify the vertices, the edges, and the faces. And we should know the difference between prisms, pyramids, cylinders, and cones. Finally, we should be able to identify what sort of cross-sections are created when we slice a plane through a three-dimensional object.